Good morning. My name is John Unthank from IBM. This is my fifth time to be here at the HPC User Forum. It's always nice to see familiar faces in the crowd. I won't recognize or remember any of your names, but it's good to reconnect. And for all the new colleagues who are here this week, I look forward to meeting with you. Regardless of the name on your logo on your business card, we share common interest, problems, and perspectives that look forward to talking with you throughout this week. When I was coming to the event, I was asked to give a brief update on IBM's HPC roadmap. And I thought, well, 15 minutes, how hard can that be? It's quite naive to think of that because it's difficult to effectively represent the size of business and scale and scope of a company like IBM with over 400,000 employees, especially in the area of HPC, but I'll do my best today. Makes it even more difficult with the time constraint we have. So consider this more of an invitation than information. We'll cover some highlights and point you to places where you can explore, welcome the conversation with you throughout the week, and follow-up sessions we may want to schedule after the event is over. The last part of that task is to try to figure out what I'm allowed to say, what's accurate, current information that is publicly available. And so it becomes a difficult task, and any time I face a difficult task, it's always time to turn to the Bible. And in this case, the Bible happens to be IBM's annual report for 2014. And lo and behold, the information that I'm going to share with you is in the first 10 pages, which is our chairman's review of an outlook of where IBM is investing in this space for 2015 and beyond. And so I'm going to share some of those insights with you. And hopefully we'll continue the discussion later. Within that chairman's dialogue, and I say chairman directly, that was one of my findings, is that our chairman, Ginny Rometty, she is a chairman, as posted in IBM's annual report. I'm sure there's plenty of analytics that went on to figure out what's the proper title, but she is our chairman, has directed these imperatives, boiled down to these five: to transform industries and professions with data, remake enterprise IT for the cloud, reimagine work through mobile and social technologies, rethink the challenge of security, and create new infrastructure for a new era. So I'm going to talk through the items that I've highlighted in bold that I think I can get through in the next few minutes, as well as I think would be most informative for this crowd. And I've tried to tailor it to a life science perspective to keep in line with the conversation we've started this morning. The couple that I'm not going to address are no less important to this community around security and the advent of mobile and social technologies, which create huge big data and computational challenges. And this is certainly an area that IBM is investing in as a transformation agent as we bring technologies to our customers. But I can attest the amount of transformation that's occurring internally is just as aggressive. As a long-term salesperson in IBM, we're moving all of our sales infrastructure to the cloud, our training, sales tools, catalogs, collaboration capabilities. Our email, traditionally Lotus Notes, is moving to a cloud-based email for all of North America within the next 90 days. It's a technology called IBM Verse, V-E-R-S-E. It will be open to the general public, so just as you can go out today and get a Gmail account or a Yahoo account, you can sign up for IBM Verse, and I would encourage you to take a look at it. Within Verse, what's been displayed to us and what will be rolled out is an advent of analytics into this email space. So using IBM Watson technologies to help through learning your day-to-day habits, your priorities, how you manage your information, providing you that automated capability through Watson cognitive support to streamline the work process and actually automate tasks for you, such as scheduling multi-party meetings around a certain topic in the future. Those can be pushed off to an agent like Watson. So the whole notion of transforming industries and professions with data is just dealing with the ongoing big data implementation and analytics. And IBM is an analytics company. We generate 20% of our revenue each year through analytics sales, software, hardware, services. That's a number we report to the analysts and industry in our Bible. So there's some proof behind it. That generates about $17 billion a year. So arguably, IBM Analytics would be one of the largest analytics companies in the world. 1/3 of our research dollars goes into analytics, and we've done over 30 acquisitions in the last few years to strengthen our position. Organically, we've taken technologies that was issued for the Jeopardy Grand Challenge of Watson, and we're pushing that into the market in new ways around the area of cognitive computing. It seems like so long ago, but Watson on Jeopardy was in 2011. So just within the last few years, we've turned it into a thriving business. There's over 4,000 companies in the pipeline that are exploring ways to leverage Watson in their environments across all industry types. It's an area of investment from IBM, over $1 billion in this space, over $100 million in venture capital being put out there for exploration of Watson. And it was interesting to see there was an announcement that happened yesterday of a whole new line of business based on Watson technologies called Watson Health. And this is creating an environment where Watson will have a health cloud that will gather data and create a central repository. That information will be available to researchers, to doctors, as a way of aggregating data across a wide array of medical devices and personal devices. Along with the announcement yesterday, there were 3 partnership activities that were under focus. One was with Apple and their health environment. How many of you have ordered or know you're going to get an Apple Watch? Anybody? Just a couple? How many have Fitbit or some other kind of device like that? A couple of more. So the Apple announced they'd sold over a million watches in pre-order. Those watches had the capability of gathering personal information like your heart rate, calories burned, even your cholesterol level. I don't know how they do that, but there's a whole collection of medical data that becomes your personal data. And then the question is, how best do you use that? One avenue is you want to get it in front of your own personal doctor so they can look for things and integrate it in your medical portfolio and be able to use that as part of your personal agenda. Another part is taking that data and sharing it for research-based purposes. Philanthropic activity, if you can assure that your information is protected and you're not exposed, it creates a great embodiment of data there that can be used for research. They say these little devices can create a terabyte of data over the lifetime of an individual. I'm sure as they become more invasive and ability to handle more and more information, that number will grow. And so the IBM business model here is to aggregate all of that data and get value out of it. It's kind of interesting, the Apple case we just mentioned is incorporating the data for public reuse. Johnson & Johnson is looking at their patients who have medical devices and implants, and if they find that your activity rate has dropped or you're not doing something you're supposed to, there'll be proactive coaching links that will be pushed out to you to help you in your recovery or medical process. The area around Medtronics is looking at insulin pumps to make sure that your blood sugar levels and the dosages you're getting from insulin are in line. So lots of ways of collecting data, this Internet of Things. All of us have become things now that we have these personal devices connected. In addition, IBM announced yesterday that we've acquired 2 new healthcare analytics companies, Exploris and Vitel, that would be put into the process. Watson, providing text-based analytics and many other types of advanced analytics, is certainly not the only tool or capability to be required here. So we'll continue to invest in partnerships and acquisitions and internal growth. And there's a link here that will be available in the charts, or you could just go to ibm.com and find more information. Now, that's a separate line of business from the Watson business that was put together last year. Watson is taking the base technologies, hardware and software, and making them available for general use, either with specific solutions for analytics or certain service types that have been defined around core capabilities. Within the area of life science, there's a number of use cases that are out there of using text-based activities for analysis through the lifespan of genomics, in analyzing clinical and personal information, doing directed research and clinical analysis of text. So a tremendous amount of capability there. If you have any interest in exploring Watson or any other technologies I'm going to be talking about today, I can help broker connection into other spots in IBM. The area of genomic medicine has been highlighted throughout the morning is a very complex big data problem. It spans a wide range of discovery types, and the capabilities around sequencing only carry you so far if you can't transform the medical approach, can't transform the ability to create new drugs and affect better outcomes. And the creation of the combination of your genomics information with your clinical and history, tying that to personal health care where it actually transforms their interaction that you have with your doctor, your pharmacist, your care providers. And so we realize that creates a number of computational challenges. So it directly impacts IBM's portfolio of products from a hardware, software perspective. Becomes quite a issue that can't be resolved with current architecture. So it's pushing us into spaces that we're defining as software-defined infrastructure, where we're using more high-performance software across heterogeneous environments to resolve technical issues as opposed to monolithic clusters or standard solutions. As part of this, we've created a particular architecture to address the issues of sequencing, pipeline, translational medicine, and personalization. So across the horizontal axis there's a whole number of processes, open source software, commercial software that has to be incorporated and managed to complete that pipeline. And you can extend the chart off the page into a cloud environment. In addition, the value of moving up the scale, of taking that data from the sequencer into translational, into personal medicine is also important. The creator of this architecture actually has some level of patents associated with this. It's interesting, you can get a patent on your to-do list because basically his requirement is to make these things fit together, and it requires a wide range of partners in the industry, in academia, and within our customer environments. So here's a brief list of places we're working with and activities that are in process. We are part of the IRODS community now, as addressed earlier this morning. Part of this consortium, we're optimizing IRODS on IBM Power Systems as well as integration with our GPFS file system. But this is a spot, as I mentioned, is an invitation for you to come and participate and be a part of this. This is not IBM's way. This is how we have to address the architecture to solve client issues. There's a article on this in IBM Systems Magazine from August of 2014. There's solution briefs and red books, but we'd welcome the opportunity to talk to you about this to see how you can participate or show us where we're missing elements in our framework. As part of remaking the enterprise IT for cloud, IBM also has cloud as a strategic initiative. Revenue in 2014 was over $7 billion, up 20%. We've made a significant investment in the acquisition of a company called SoftLayer, that's a hosted cloud company, and we've invested to expand and create additional hosting centers for that kind of capability, as well as a significant investment in taking IBM's software portfolio and creating an application development portfolio in the cloud. In addition, we've created an offering that is a high-performance cloud. So it exists in our SoftLayer data center where we provide private servers multi-core that can have private VLANs be created as a hosted cluster, supporting significant scientific and technical technologies for like multi-core servers, InfiniBand, parallel file system, advanced workload schedulers, as well as systems administrators and architects can build that for you in the cloud if it's an area you want to augment your capability. And certainly we are key supporters of OpenStack. You'll see that across our solution portfolio for those interested in building on-premise clouds and developing your own shared capability. In the area of workload scheduling and management, this notion of a software-defined infrastructure, we've been in this business for quite some time with the platform products, LSF, for high-performance computing workload scheduling. But what's happening in the environment of incorporating analytics and other kinds of low-latency services or longer resident services scales beyond the capabilities of a single specific workload scheduler. So we've created a family of systems so that you can leverage and share a tenancy vertically over those kinds of applications. You can also integrate and share across resources to bridge and incorporate high-performance workload with big data analytics and non-traditional services. We've tied this into a data management layer, which is our new family of products called Spectrum Storage. This was announced last month that we are investing in an environment called software-defined storage. Initially, we'll be integrating together existing technologies from IBM products you may know, like GPFS or Tivoli Storage Manager, LTFS, and bringing them in a family of products to integrate across them so that we can manage block, file, and object storage with single layers of control and protection. So I'm sorry to say to many in this community that GPFS is no longer a product. It is now called Spectrum Scale. It's an elevation of status in IBM as a standalone brand. Considerable investment behind this stack, over $200 million a year over the next 5 years, so $1 billion investment to tie these pieces together and extend capability. Last but not least, many of you may have thought this would be a discussion on IBM Power Architecture. It's fundamental to our success in high-performance computing and exascale computing. We've directly tied it to our innovation capability through the Open Power community, a consortium of users that are developing ecosystem around power processors. It has a wide range of members. Anyone in this room, your companies can join and be a part of the Open Power Consortium. We, as a business, will be delivering power-based servers for this marketplace. Long-term roadmap is very tight integration between our Power 9 technology and NVIDIA GPUs. We have Power 8 currently in our product set today. Power 9 is in our near future that will be focused on leveraging all of the innovation that's brought forward by the Open Power community. While we still have a lot of work to do, there's been some early success in this area. Through the Coral program, this technology around Power 9, NVIDIA, and Open Power capability was selected by Lawrence Livermore and by Oak Ridge as their next generation supercomputers in the 2017 timeframe. So there's a reality there. While we have a roadmap and a lot of work to do, we do have a vision, I think, that will be important in this space. We'll continue to be a player in the hardware marketplace. We'll continue to invest in our software-defined environment for heterogeneous solutions and to leverage the best of breed that comes along. Again, I'm short on time here, so I'd like to end at this point and welcome future conversations with you. Thank you.